Hello everyone, in lecture 37 of PEC, we will introduce two applications of the Thevenin and Norton theorem. Firstly, we will discuss the input and output resistance of the voltage signal processing circuit. In previous discussion, we always focus on the one-port network. Its input resistance is often called Req or Ri in the Thevenin theorem. It's a resistance of the network with resistors, dependent sources, but without independent sources, seen from the two terminals. It can be solved by U2I method or by I2U method. We can also calculate the ratio of the open circuit voltage and the short circuit current to get the input resistance. Of course, there are independent sources in the network in this condition. We've discussed them in previous lectures. In fact, the common signal processing circuits have the input and output ports respectively. Suppose the signal is transmitted from the left to the right. In this condition, we often discuss the input and output resistance of the signal processing circuit. The signal processing circuit's input resistance is the input resistance seen from the input port toward the output port. Sometimes the output port is connected with a load resistor. Sometimes the output port is open. We will discuss this point later. The signal processing circuit's output resistance is the output resistance seen from the output port toward the input port. It's a one-port network with independent sources. Its Thevenin equivalent resistance is its output resistance. Let's discuss the requirement for the input and output resistance seen from the signal source and the load respectively. Seen from the signal source, it's a circuit we are familiar with. In order to get the maximum input voltage, its input resistance should be as large as possible, or the inner resistance of the signal source should be as small as possible. This is the condition seen from the signal source to the right. Seen from the load toward the left, the circuit with the signal source and the signal processing circuit can be equivalent to a Thevenin circuit. You are familiar with the circuit? In order to get the maximum output voltage, RL should be as large as possible. Furthermore, we can also make RO as small as possible to provide the larger voltage for the load. So for a voltage signal processing circuit, it should have the large input resistance and the small output resistance in terms of the voltage signal transmission. The other requirements for the voltage signal processing circuit will be discussed later.